What is up, everybody? Welcome to the stream. Happy Friday. It's good to see everybody. It's about to be the weekend, and what's more than that is that I'm about to go on vacation. It's going to be great. Haven't been on vacation since January, something like that. So looking forward to it. Going to be going hiking upstate New York. Going to go to the Adirondacks. It's going to be great. If you've ever been in the Adirondacks, if you've never been in the Adirondacks, it's beautiful there. Lots of mountains. There's some little towns, sleepy, good hiking, good views, good waterfalls, good rivers, good streams. You know what I mean? And we're not talking about the Kafka variety of streams. You know what I'm saying? We're talking about the real life ones with the rocks and the rills and the water. So I'm really looking forward to that. I think it's going to be great. I think I need the time off, need a break. I don't know if I'll be around to stream on Friday. I probably won't, since I'll be away. But we might come back. We might come back on Friday. We'll just have to see. I'll tweet about it. Pete, it's great to see you. It's been a hot second. I hope you're doing great. Where did you go in the Adirondacks? Sora, by the way, hello. Godwo, hello. Yeah. Of course it was nice. It's always nice there in the Adirondacks. That's just what it's like. Pete, I hope you're doing great. I hope you're having a good summer and etc. Having a good time in life. So what is gonna happen today? I think basically I have a bit of a shorter stream plan today because there's a bit of a birthday party for somebody after the stream. I'm gonna hit up that birthday party. By birthday party, I really just mean dinner with somebody for their birthday. It'll be nice. It'll be nice. We got them some flowers. It's my girlfriend's sister, so that's who it is. We got her flowers. We got her some gifts of food and various things. And that's kind of what we're going to be up to. So it'll be a shorter stream, 2.5 hours, something like that. Thought we could look at some Execgen stuff. It's been a little bit of a long time since we've looked at Execgen stuff. So should be good. Should be interesting for the people who haven't seen it. I hope they won't be too horrified. Mount Marcy, that is cool. Mount Marcy, that's the highest mountain in New York State. I'm sure you know that, but for everybody else on the stream, highest mountain in New York State, 5,200 feet, something like that, right? 5,200, 5,300. The thing about the Adirondacks is they've got all the highest mountains in New York State. And here in New York, we're not talking about 14,000 foot mountains. We're talking about 4,000 foot mountains. And it turns out that there's 46 of them, 46 mountains higher than 4,000 feet. Or at least they were higher than 4,000 feet when they surveyed them. Now I think some of them are like actually 3,900 or something like that. But anyway, there's 46 of them, and if you complete all 46, if you hike all 46, get to the top of all 46, then you're a 46er. And so I've been working on my 46ers since I was about 9, little by little, slowly by slowly. And this time I think we're gonna hopefully get a couple more 46ers down, get them done, feel accomplished. Haven't been hiking in a long time, so hopefully my legs won't become jelly, but it's always a possibility. Monomorphization is horrifying. Well, is it? I think it's something that a lot of compilers do it, but maybe it sounds kind of horrible. Can't figure out what it is looking at the Wiktionary. Yeah, so basically what monomorphization is taking a generic function. And I don't mean generic in any sort of way. I just mean a function that can work on many different types in any way, shape, or form, and generating n copies of that function specialized on type or specialized on value. That's also a thing. And in fact, that's kind of what we do more of in Cockroach. We monomorphize based on values and not types, really. C++ templates at its root exactly. Pratik knows where it's at with the monomorphization. So that's kind of the idea. We have this sort of janky thing that we rely on quite a bit, actually, for... Yeah, so generics plus code... I mean, basically with generics, depending on the language, like in C++, they call them templates, but they're kind of similar to generics. And the way that they work under the hood is they are just code gen. So C++ templates are just a fancy way of doing a bunch of code generation. In Java, I don't exactly know how Java generics work. I imagine that there's some monomorphization and code gen there as well, but I don't exactly know. It's maybe not quite as simple as C++ templates, which obviously are not simple in themselves, but I think the concept is simple. And I think that there is a preprocessor that C++ runs that you can just run yourself, I think, right? And it'll spit out the code after the template runs, and you can kind of see more straightforwardly what's going on. I think that's how it works. I'm not positive. Never really tried that. Java would need to generate some code since JIT needs to do its thing. Yeah, exactly. Yeah, I don't know if it's going to put it into the compiled classes, though, or just have the engine do it on demand. I just don't exactly know how that works. But yeah, I don't know. It's interesting stuff, though. So I'll show you what we do in Cockroach. Wabam. So what we do in Cockroach. What do we do in Cockroach? Basically, let me show you an example. Should I show you a complete example first or like a toy example? Why don't I show you a complete example first? So I'm going to go to this file, vec.eg.go. Oh, toy, you want toy? Okay, we'll do toy. We'll do toy. We'll do toy. We'll do toy. So here's a toy example. This is the test cases for this Execgen tool. Safe, what's up? The test cases say something like this. Check this out. So we got a function, and it calls this other function b twice. Once it calls it with true, and once it calls it with false. And inside of this b function, check out what's happening, is we say we have a little if condition. If t, then this thing, else this thing, then we return this thing, right? Never mind that the syntax doesn't really make that much sense. It's just a sort of, there's no like assignment here. It's just a, yeah, example. But check this out. There's a little special annotation here. It says Execgen template t. And what that says is that for Execgen, it's going to notice that there's a parameter called t here in the arguments. And it's going to know that this is a template argument, or like a compile time argument, basically. And using that information, it's going to spit out code that looks quite different from what it's looking like here. And I'll show you what it looks like by scrolling down. So this test format, basically it's like, here's the input, then we've got these two lines, and there's the output. So let's take a look at what the tool generates given this input. So it generates this. And what's going on here is that instead of having functions with arguments at this point, since we only had one argument and it was a template argument, what the program actually is going to do is it's going to replace it with a concrete call to a new function, be true, which is a specialization of b given a pinned value for that template variable, right? So there's going to be two variants since we've called it twice with two different values, one for be true and one for be false. And over here, when we call it, we're calling be true and be false instead of passing true or false as runtime arguments. We're sort of passing them as compile time arguments, aka figuring out a function to call that was precompiled. And if you actually look at the definitions of both of the functions, there's something cool going on, which is that these conditionals have been folded or deleted altogether. So check this out. X equals 3, return X, right? That's because t is true, X equals 3, return X. X equals 4, return X, because t was false. So this is kind of the idea here. So Safe says, how would that differ from compiler time eval, like C++ optimization flags? It basically doesn't. And if Go had compile time macros, I would definitely be using those here. But Go does not have compile time macros of any sort. So we kind of had to make our own little thing to do this. So what's the use case? That's a great question from God Woe. What is the use case? I think to help you understand what the use case is, I'm going to have to show you a real example. God forbid. Actually, I'm going to construct a little idea for you so that you can kind of understand where this is coming from. I'm just going to do it in a random file. Like, I don't know. I'll just go to the bottom of this file and make an example. Does the unmonomorphized code have to be valid Go? It doesn't. It kind of does. It has to be like parsable because we do AST manipulation to make all the transformations, but it doesn't have to be syntactic or like semantically valid, which is why it worked when I didn't have a proper variable declaration form instead of, I was just doing like X equals, which you can't do if X isn't a variable yet. So it has to parse, but it doesn't have to like be semantically valid. So let me write an example function here. I'm going to say funcf. And what I'm going to do here is I'm going to, as input, I'm going to pass in let's say we're doing a database thing, right? That's because that's what we're all about here on the channel. And we're going to be passing in, oops, that's not how we do anything in Go. We're going to be passing in like a column of data. So we're going to say something like, let's maybe say, we'll say some values, okay? And some values is going to be, it's going to work on multiple different types of thing, because we want our sum values to work on both integer, int64s and int32s, let's say. So here's how we're going to write this function. We're going to say, basically, we'll say something like, well, actually, I'm going to make it a little different. I'm going to make it look like this. Instead of this interface thing, that can come later. I'm going to make it say, see, you know, any data type, right? And any data type is going to be a type struct. It's going to be a type, type. We'll say interface. Wait, that's not how we do things in Go, is it? We say type any data type interface. And I think what we'll do here is give the any data type a sum method or something like that, or like a plus method. And it takes an any data type. This might be really confusing, honestly. And so basically what I'm trying to get at is like in this any data type thing, the code that I would write would look something like this. I would say like for I in range C, I'm gonna get like my thing, my like data is equal to C of I. But my data is now like this any data type thing. And basically what I have to do is I have to figure out what concrete type it is. And I can either do that using an interface call, like this thing will delegate to the concrete implementation, or I can do it with a type switch. Let's say for now, I'm gonna do it with a type switch. So I would say something like, you know, like x var s sum, var s in 64, we'll say, this is our sum. And I'm gonna say something like switch d dot type. And I'm gonna say case in 64. And I'm gonna say case in 32. Never mind that this isn't really valid Go right now because there's some there's some messed up stuff about how the types work. And I would have to do more work to make this actually compile. But just to give you an idea here. So if I see an int64, then I'm going to say sum plus equals v like this. And if I see an int32, I'm going to say sum plus equals, I'm going to have to cast this to int64 or something like this. All right? And then I can return sum. Okay, so the question basically for God Woe is why is this slow? Why is this inefficient? I'm not going to give you too long to think about it. I'll just tell you the answer. The answer for why this is inefficient is that on every thing, on every element of this loop, which is a slice, we have to check something. We're having to check the type. Exactly, it's dynamic dispatch. We have to kind of check what's going on, look at the type, you know, introspect the interface. If we were calling this plus method, we would have to like do whatever Go does to have to convert the interface into a concrete type and find the function. It's slow, especially when we're talking about making something as efficient as a database, which really should be able to process a lot of data very quickly. If we wanted to just do something as simple as sum a bunch of numbers, we really wouldn't want to have to do these branches and these interface introspections on every single value inside of the branch. So the solution is to kind of switch where we're doing these type checks. And an example solution could look like this. Instead of taking a C slice any data type, we're going to be taking a C interface. And we're going to be putting a type switch up top. We're going to say switch C dot type. And we're going to say case in 64. And then we're going to say case in 32. And inside of these cases, then we can have really, really nice and fast code that kind of looks like this. For I in, I guess it has to be like this. For I in range C, sum plus equals C of I. And then it's basically the same thing in 32 land. For i's in range C, sum plus equals int 64 of C of I. So you see how this code, these little for loops are much, much, much more tight and efficient. It turns out that the CPU can execute this stuff much faster. And this is kind of the key optimization or observation for this vectorized engine thing that we've had in Cockroach for a couple of years now. Okay, so why Execgen is the next question. The answer is that in a database, unlike this toy example, there's not just two types, int64 and int32. There's like a bunch of them, like 20 or more. There could be user-defined types. It gets complicated. So, and you really don't want to have to rewrite this code for every operator. Let's say you got your join, your sum, your aggregate, your distinct, your sort. There's all these operators, and there's a crap ton of code to write. And you really, really wouldn't want to have to, every time you add a new type, add a new loop. Every time that you change a loop, change all the loops. That's horrendous. So the answer is that you have to find some way of either generating this code or getting generics in your language that are specializable. The reason that they need to be specializable is a little bit complicated, but basically it's that not every data type is representable as a native slice in SQL. So you have to be able to, you can't always be like slice indexing onto this stuff. Sometimes you have to say .get or whatever. And so there's a bit of differences, and it's basically, it just is the case that you have to specialize some of these loops. So you can't really use a basic generics package, unfortunately, like the one that Go2 is going to have, because it doesn't have specialization. So you have to use some sort of template language, template engine, whatever it is. And we ended up writing one because you kind of needed to do it. You needed to find a way to make it work one way or the other. Text, we started with text template, which is Go's template, basic, like template interpolator. But there's common features, there's things that you want. So we started kind of making a little mini language that does some of this stuff automatically. So this is the idea, basically templating, exactly, Techie-chan, perfectly correct. Java, instead of generating code, erases the types. Foo T-bar becomes foo. Project's a bit out of date. Well, I mean, honestly, that's not out of date, because this is the reason that I got back into this Execgen stuff. In the first place, I was doing this work. I was like, oh my God, our template engine, it's not good enough. I forgot how it worked, and it's too complicated, so I want to make it better. String bar. Yeah, well, I don't know. Yeah, that's interesting how Java works. Anyway, so this is basically the idea. Let me show you a concrete example of what this actually looks like in practice real quick. So if I go over here to vec template, well, is this going to be a good example? Is this a good example? So I think this is actually a pretty good example. Well, is it? Is it? Let's do, I've always liked the distinct template because I think it's kind of cool. Let's take a look at the distinct template. So here in the real example, we have something that basically, we want to create an operator that works with every type. And so this is the output of the code generator. When you pass in a sort of generically typed column into this function. So this is this t types.t thing. This is like a SQL type. Then what we do is we determine which of the SQL types we're looking at. So is it a Boolean? Is it a bytes? Is it a decimal? Is it an int? And we return a type-specific operator that has all of the types sort of pre-calculated, so it can be really, really fast. So cool. See you later, Sora. Thanks for hanging out. So if I take a look at distinct float64 op, here's a full struct with all sorts of code and logic that is completely type specific to float64s. It's also, you can notice there's a lot of sort of manual inlining stuff in here as well, but that can come later as well. The point is that this column is a float64. Like what this thing returns is type specific float64 slice, and ultimately under the hood, it's going to be this slice of float64. So it can all be very efficient, but the question is like, how do you generate this code in an efficient way? Blah, blah, blah. So it's verbose and stupid, and not to mention all of the actual operator implementations themselves are type specific and generated. So what does it look like in the template? I'll show you that next. So inside of this distinct template, instead of that huge type switch, we have this is like really kind of simple inlined. So there's like a combination of two things that we do. One is like basic text template declarations that you might have seen if you use text template. We're saying, for every type family, in some list of type families that we've provided elsewhere, output a case statement. For every width supported in this particular type family, output a width statement, a width case, and then return the specific one that is matched. And we do some like magic that honestly is possibly just more confusing than it has to be to replace some of this stuff, so that when you see this, underscore type, you're actually getting some string that will link it up to the implementation that we generate later. And yeah, so stuff like that. Basically, this is kind of like the old school way that we were doing this templating stuff, because, well, it was sort of the most complicated form when it has all of the different types to generate, as opposed to some other cases where it's really just like some simpler switches, like Boolean switches that want to be completely monomorphized. So this is kind of like the old school way. There's no annotations here, really. It's just like text template declarations, basically. The new school way, which I think is pretty cool, is it looks like this. So I'm going to show you an example. Datum to vec template. Wait, vec to datum template. The new school way kind of looks like this. So instead of having a bunch of kind of inline declarations, we can kind of use these directives that we've made up. So there's kind of basically two of them. There's Execgen inline, which takes a function that would be a function call, but kind of like textually inlines it. And then there's like this template thing, which allows you to, right, we went through this earlier, but has cell and deselect are both kind of template time variables. And so when we eventually call this thing, I guess in this case, we have other template parameters that are passed in, but at a certain point, you have to actually like concretely instantiate the function with like a literal, which is, by the way, something that I really want to find a way to fix it, because it's kind of like one of the big things that's holding us back from working in the more complicated types case that I've been talking about. The fact that you have to actually literally write out, true, true, false, or whatever, true, true, false. If these are template variables, you actually have to have somewhere in the code that has a literal Boolean value, or in the case of types, a literal types value. And why is this bad? It's because even if you genericify a bunch of code to like start the process of generating all the different type specific ones, you actually have to write a call to them with all of the different types, which ultimately is going to force you to write code that looks like this, right? So it's like, depending on the type, are we going to do a bool op or a bytes op or a decimal op or an int16 op? You know what I mean? You still have to do these big type switches, and I don't like that. So one of the things I want to fix is like, how do we provide a list of all of the specializations that we want to create ahead of time? It's kind of meta, right? It's like, you really want to be able to pass a variable with a slice, but the problem is that Execgen can't read runtime values like that. So basically, I don't have any idea how to fix it yet. Is Execgen on GitHub? Yes, it definitely is. So it's just inside of the Cockroach source code, but it lives, I'll show you. And I can show you kind of how it works under the hood as well in a second. Where is this thing? Is it in here? Call Execgen. So it lives over here. And yeah, so let me show you an example of kind of how it works. So if I go to this template.go file, which is the file that implements the Execgen template declaration, basically what it does is it takes in, where's the kind of root thing here? I think it's this one, right? Expand templates. Yeah. Okay, so here's the call. It takes something called a dst.file. A dst.file is like it's basically an abstract syntax tree of the Go code itself. And it does a couple of things. First, it like iterates through everything, searching for funcdecls, and it searches for funcdecls that have been annotated with Execgen template. And it kind of parses them apart. It finds the different variables inside of the template declaration. It like sort of validates them, or attempts to, with the variable, I guess it's sort of the formal parameter names in the functions. It like figures out some information. It modifies the AST a little bit, blah, blah, blah. Then the next step is kind of the important one, which is this replace and expand templates thing, which basically searches for all call sites of the template functions. And then it's going to parse out which concrete values it was called with. And so for each of the concrete values it was called with, it's going to generate a variant, which is, I think, essentially what C++ templates do, right? It's like they can't possibly know all of the different possibilities for a particular template, right? Because it could just be an infinite, sequence. If you had like an integer as part of your generic parameter, it couldn't generate all variants. You would have to actually find all the static spots in which we invoke these things and generate just those ones. So that's what we do here. We find all concrete call sites. We write down a list of all of the different values that we call the function with, and then we generate just those ones. And then I guess the last step is that we do some inlining stuff, right? We're gonna like basically, so we find the concrete call sites, we find all of the declarations and replace them with the monomorphized copies. And then the cool thing is actually that we actually, where is this thing? Is it in here? Yeah, we have this sort of fold conditional steps, which I think is super sick. Basically, fold conditionals is it searches for if statements and case statements that like have lexical, either Boolean or lexical matches, and it folds them away. So that's how we were able to get rid of those if true, if false things from before, is that we kind of notice them and delete them. It sort of works with, Boolean expressions of Booleans, like, true and false or something like that. And it also works with switch statements that work lexically in a sense. So if I say switch X, and then there's like a case Y, case B, case A, case X, it's going to find X equals X and replace it with just that case arm, basically. And that's kind of how we can implement some of this cooler stuff. So if I show you the test cases again, like if I go down to the bottom where I added this latest test case, this is kind of the most advanced one that I did. It's basically, all right, so I have this frobnicate column function that I made up as a test case. It takes a call data.vec, a family, a width, and it does this switch statement stuff, right? It's going to say, okay, am I an integer or am I an interval or an interval 2? And if I'm an integer, am I a width 32? But I've actually named family and width as type parameters, right? Or as template parameters. So then when I call them over here in other func, what I actually see is that I'm calling it once with int and then 32, and then interval and then 0, and then interval 2 and then 0. And then I actually go and replace each of these call sites with a concrete representation of the monomorphized copy, basically, right? So I say frobnicate column types.int32. That means that I'm doing this version. And the key coolest thing, though, with the conditional folding is that in the implementation of each of these concrete ones, you can see that there's no ifs left, right? So we like completely deleted all the ifs. And the reason we were able to do that is that you can see that we lexically match the different things. Like we know that we're passing this thing as family, and family's over here. So we lexically match it. Family equals types.int, just as a string. It's very janky. It's not like particularly legit. And if these were like, I don't know, uncomparable values or something like that, it just like would not work at all. But the point is that you can do kind of cool stuff with this just by lexical string matching. So does that make sense? Who has any questions? I really want to, like, the next level is going to be figuring out how to use this stuff to get rid of this crap, but I don't really know how to do it yet. So let me show you the project that kind of inspired this change stuff. Does this ever make you doubt Go? It definitely makes me a little bit sad that like they don't have generics with specialization in Go, but I don't know. It's not that bad. It's not that bad. I know regular Go, but how do you get into this type of meta-Go, messing with the language itself? It was just out of necessity, Gomi. I mean, like, I basically wrote all of this stuff, so it's not like I had to learn it past doing it, so to speak. So, I mean, and yeah, the reason that I quote unquote got into it was just out of necessity. We knew that we needed to make these tight type loops, right? And the question was, how do we generate that code? And this is sort of the system that grew as a response to that requirement. One plane, what's up? Prime.cpp. Functional Go. Don't know. Currently implementing some data structures in C to brush up on C, and this seems way better than void pointer. I mean, maybe void pointer. You got a lot of power with void pointer, right? Staring into the void, the void stares back, right? So, okay, look, guys. remember what we did last week? We were starting to look at, did we do this on stream or off stream? I can't remember. We eventually, wait a minute, what's going on? We eventually, wanted to, okay, what did we do last stream? Oh my God, bots, dude. What the heck is this bot crap? Get away, the bot. Yeah, so last stream we looked at making lookup join more efficient, maybe? Is that what we were doing? Memory management stuff? I think either at the end of the stream or after the stream, we started looking at what could we do to make this index join stuff vectorized, which would be a dream if we could find a way to do this. And with index join, right, one of the key challenges is that we want to be able to generate these spans really efficiently. And if we're generating spans efficiently, what that reminds me of is like, oh man, this is a perfect vectorizable operation. A span is like taking multiple values and encoding them one by one into a string so that we can send it to the backend database and have the backend database give us back what's at that span. And if you have like 5 columns, that's a perfect example of this type specific stuff we've been talking about, where it's like you want to do a big loop of all the integer columns and then a big loop of all the string columns, right? And then keep kind of appending to these key spans that you're generating one at a time, rather than having to do like n different types per row. It's like, are we doing a compiler or an interpreter, right? That's the key. And so I was looking at that and I was realizing, man, okay, if we want to do this, we should really code generate this span generation stuff so that it can be type specific, just like we've been talking about. And I was looking at that. So let's take a look at what we've got so far. Key encoding template. I was taking a look at this. I was like, oh my God, we really want to have a function that's like this. It's going to be Execgen templated, and it's going to take a family and a width and a direction, which are the 3 kind of core things you need to know in order to figure out how to encode a particular value in a span. And then I was like, oh my God, the template language doesn't let me do this. So that's what I've been kind of struggling a little bit with. The true dream would be like, we would make this kind of template function that look how this like kind of works the way that we want it to, in a sense, right? We get a family, we have this big switch statement, and right, this looks like normal Go, but it's not normal Go because these case statements are going to get completely deleted later, as will this direction thing, right? We won't have to care what this direction is. It's just going to be like this line of code that's going to get generated. We'll have this basically like encode val Boolean ascending, and it's going to give just this back, right? And so then we would be able to actually call this thing from somewhere else, right? And pass through those template parameters, right? So that's what we've got going on here. Encode callback to spans. It's going to take a family width and a direction, and it's going to pass that through to the right implementation of encode val, right? So it's going to be the specific type specific one, right? So all good so far, but we ran into this problem, which I tried to talk about a little bit, which is that how do we get the program to know all of the combinations of family and width that we're going to be calling it with? This is the key thing that's holding us back right now. And what we used to do is we would use text template, so like the old school Go way of doing things, to pass in to some other file a list of structures that contains all the things that we want to be passing in. And that's why there's sort of these like range widths thing. These are helping us iterate through some structures that are passed in to the template or somewhere else, but it's all like kind of custom. What I really want to do is find a sort of Execgen annotation way to generate this code. You know what I mean? It's like, what would be the syntax that we would want? It's almost like I would want to say something like, I mean, the true coolest thing that we could actually do is, let's say we had a genius engine that could figure everything out. What we would say is we'd say encode callback to spans. We'd pass in vec, we'd pass in cell, we'd pass in spans. And then instead of passing this sketchy template variable, we would literally just pass t.family, right? If we don't have a t, why is that? I guess we'll have to say t is equal to vec.type. Yeah, it does have a big impact on compile times. Not a big, like the Go compiler is extremely fast. But yeah, it takes some time to produce the generated code, and the generated code is huge. Like, let's take a look at the hashtable.eg.go thing. So here's a file that is, let's find out. you know, 8,000 lines of code, and there's like a whole bunch of them. Let's just take a look here. What do we got? Let's cd package SQL call exec. So you guys are gonna love this. You guys are gonna actually love this. We're gonna say wc-l star.eg.go. So we're talking about, well, this isn't that bad. 23,000 lines of generated code. But I think that where's the other generated code? I guess we should do like, oh, the really big ones are these projection ones. You're gonna love this. Check this out. ls-l or wc-l star.eg.go in here. Here we're talking about 159,000 lines of generated code, guys. Totally legit. Totally legit. Here's the thing about the generated code is that you don't have to review it, right? Because you trust the templating language. That's the point. That's the point. So don't freak out. It's gonna be fine. You don't have to worry about it so much. Here's the selection ones. ls-l or wc-l start.eg.go. 62,000 lines. No big deal, right? How about call exec join? 126,000 lines inside the join package. You know, you guys get it, right? You got to have a lot of generated code. It's the dream. Because, okay, look, the point of all of this, remember, yes, it's a lot of code. It's generated. It gets a big binary, but it makes the thing go really, really fast. Because the point is that you have all these type-specific loops encoded into the binary. And when the program runs, when SQL runs, it's going to pick out just those little correct type loops and get to run them extremely fast. And in practice, we see this working very, very well. Kind of like we saw like a 4 to 5x speed up on a bunch of queries after doing this engine. So we think that that's pretty good. It makes the original templated code so much easier to read. Yeah, that is hopefully true. Right now, it's not exactly that true because of some of these problems, but we want to make it better. So right, like the true dream here would be like, what if we could say encode call vector spans t.family, t.width, and then direction, right? So why, like if we could do this, this would just be like truly the incrediblest, best dream ever. But do you guys know why we can't just do this right now, given the engine that we have? Why do we have to have all this weird type switching stuff? Why is it so disgusting? The reason is that the basic reason is that like how are you going to do that? By guessing. The tool that inspects this call and notices that there's family, width, and direction and they're template variables, it has to be running at compile time. And at compile time, we don't know what t.family is going to be. We don't know what t.width is going to be, and we don't know what direction is going to be. It turns out that there is like a finite set of the families and widths that could appear here. Like I know what they are. I could tell you what they are. There's like, 20 families and 3 widths and 2 directions. But how do we instruct, like what I want to solve syntactically in this like little language we're building is how do we instruct the Execgen compiler about which values it's going to see and which values it should be generating variants for. You know what I mean? If we did that, then we could actually make this happen. What we would do is we'd first generate all the variants. Then what we would do is we'd generate this little helper. It's almost like a V table, if you're familiar with that stuff from other languages. It would be like a little lookup table. It would say somewhere else, okay, let me check the runtime value of t.family, runtime value of t.width, runtime value of t.direction, and then jump to the right implementation that was pre-created at compile time. I could write that code. What I don't know how to do is write the code that gives us all the options ahead of time, because I don't know what the right syntax would be, and I don't want to make it something that you have to like repeat all over the time every time you want to do one of these special methods. Like here's an example of something we could do. Right below Execgen's template, we could say Execgen instantiate. Then we're going to say types.int family 64 encoding.ascending, right? And then you have like a bunch of these, So you got 32, you got 16. Then here you don't need a width, float family. And you got, decimal family. And on and on and on, right? But then you'd also have to do it once for every encoding dot ascending and descending pair, right? Like this. Like this is horrendous, isn't it? You don't want to have to write all this stuff out. So what do we do? Who knows? Does anybody have a good idea here? Like this itself is generated code, right? This should be generated code. We should find a way to generate this stuff, but I just don't know the best way to do it. X, M, cham, or X. New here, no clue. Brief context. We're working on a distributed database. It's called CockroachDB. It runs SQL. What we're working on right now is this little mini language and program inside of the database that's used at compile time to generate type-specific code for SQL queries. So that when you run an int, like a select count star, or like select sum of some int column, it's really fast. And when you say select sum of a float column, it's also equally fast. That's the general idea. Type-specific operators. Something like this, instantiate dot 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 ascending, descending. So you could have like this to show that it's like you're doing both of them. I kind of like that. That's kind of cool. So then if you have brackets, it means that you're going to do every possibility up front or something. Like the thing that you really want is you want to be able to link it to like a runtime structure, right? You want to be able to say execgen instantiate, and then you need to pass it like a variable. Maybe, let's say we had a variable over here that was like, maybe it was like var alt type families. You know what I mean? And this was like a types.family. And then at init time, you could say func, well, I don't know what you do. Let's just say it's like this. Types.int family. You know what I mean? And then you could say like, okay, instantiate all type families, and then like, all widths. All directions or whatever, and then you'd have to just do it once. The only thing is that with this one, it would generate too many values because like not every family can take all the widths. So you'd kind of want to pair these two up somehow. But the main problem with this concept is that we don't have a way right now of Execgen doesn't know how to like parse actual runtime structures like this. It's just too stupid. That being said, what if we just taught it to do that in a very simple way? Not like in a way that would really work in general, but what if it just like lexically parses it? Because the parser will give you back all of the values inside of here. I mean, I don't know, this feels like a little wrong. But maybe, I don't know. So let's say we did that, right? There's still like one more problem to overcome is the thing. Even if we figured this out. There's one more problem to overcome. And the problem to overcome, or is there? So the problem that I was talking about, multiple instantiate statements with each valid combination would be clear. So the only problem with that Sora is that we have like a bajillion different little functions that we're going to want to do this to. So we wouldn't want to have to, if there's like, let's say 40 little comment lines, would we really want to repeat those 40 comment lines on every call site or every function that does this? And then every time we want to add a new type to the thing, we'll have to find every instance and edit it. You know what I mean? It's like, ugh. The code reuse, it really is brutal. Does generics help with this problem? Yeah, so I wish that it helped with this problem. The go-to generics proposal is really cool. It does a lot of good stuff, but it doesn't have type specialization. That's kind of like one of the things that it does not have. And unfortunately, that is a blocker for us. Instantiate int 16, 32, 64 axdec and a new line for other types. Yeah, that's a good point. Yeah, so let's take a look at what that would look like. So it was like this. And then we had, well, again, the problem with this is that there's going to be, this is such a huge list of things. Types.float family, types.interval family. You know, there's like a lot of these and it would go off the screen. So I don't feel great about that either. It kind of has to be, it has to be like linked to a runtime variable, I think. But yeah. Generics will be in Go 1.18. Yeah, the only problem is that they don't have type specialization. So I don't know if you're familiar with type specialization, but the idea with type specialization is that in a language generics, it lets you make a different implementation of a particular generic function depending on the value of the type that was passed in. Go does not have that capability in its new Go generics proposal. So unfortunately, it doesn't really help us. A top-level Execgen instantiation list that you reference by name later. That's an interesting idea. Yeah, so what if it was like this? What if you said Execgen instantiation list? What if you said instantiation list? Execgen types. Execgen what if it was like let, and then you say a name, all families, and then you set it to a value. The only thing is, like, if you do something like this, then it's sort of like, why wouldn't you just have it be a runtime thing that gets deleted later and just call this an execgen let? You know? I feel like I like this kind of. I feel like I kind of like this, sort of. Like, what if we did this? What if we did this? And then we did execgen instantiate all type families. Execgen instantiate all type families. Okay, so here's another question. Now, if you have a variable in here, like how is it going to distinguish between this variable thing and like a concrete value? You know? All type families, all directions. Coding.direction. I feel like the width thing is just crappy, and I wish I could delete it. It's awkward that this width thing, it's only important for integers. Everything else ignores it. It's almost like we really want to have a... We really want int32 family, int64 family, int16 family. That would really simplify things, but we can't do that for other reasons. Yeah, it's a little annoying. Parsing Go syntax is more work. No, so that's the thing. Sora, it's so easy to parse Go syntax. I'll show you how that works in a second. It's really easy. REST API development, yeah, I think that Go is a great language for doing REST API development. Have a separate instantiate without width for every family other than int. The only problem with that is that you need to somehow link this stuff all up, and you kind of need the width to be propagated through I don't know how you'd avoid it. Because you see how it's like, it's going to get called by encode call vector spans, width, and you're going to call encode val, it needs the width. Then only down in encode val do we actually check the width. So you kind of need to pass it. Or wait, we don't need, we like, oh wait, do we actually not even need, oh, yeah, we do need width. Oh yeah, this is the other annoying thing, you guys, is that there's this missing piece that I haven't explained to you yet, which is this vec.template type thing. So basically, what is a vec? Vec is this interface that has type-specific methods on it. So look, I've got this vec. It's an interface. How do I get out? Let's say I know it's a Boolean slice. How do I get out the Boolean slice? Well, I have to call this bool method, right? It's like this. So I know it's an int16. I have to call it int16 slice. But I have to get like, how do I now? So one way I could do it was I could say something like this, you know, switch family case. Case types int family float family bytes family. See you later, Godwo. Thanks for stopping by. Decimal family, right? So here's some options. Then I'm going to say something like, you know, call is equal to vec dot int. Well, this is where I need to check the width, by the way. So I'd say switch width, case 64, case 32. What's really more like this? So you kind of see what I mean here? Like you have to have this like weird stuff. And unfortunately, these columns are also, they're sort of typeless. It's sort of important that these things are typeless in the sense because the template code needs to treat them as just regular slices later down. They have to be concrete, rather. They can't be interfaces. That's the key thing, because the interface indirection is too slow for us. Then we go like this. You know, we go like this. This is going to be float 64. This is going to be bytes. This is going to be decimal, right? So the question is, how do we avoid writing all this code? That's another an irritating problem. I think the answer is that we can write an inline template function, an inline template function. Oh, I think I already started doing it up here actually. Get type column. So we can use get type column as a way to fix this. I forgot that I already wrote that out. So basically what we say is we say call is equal to get type column. We pass in vec, we pass in family, we pass in width. And the weird thing is that this thing is like typeless in a sense, but that's okay. It doesn't really matter too much. Anyone ever said that you look like Ibrahimovic? Yeah, people were saying this like a couple times ago. I guess I'll take that as a compliment. Thank you. All right, so once we've got this, we can actually throw away the width information, which is cool. So let's delete that from everywhere. Throw away the width information because we don't need it down here. This is completely width agnostic once we've got the value that we're passing in here, which again won't be a real interface. It's going to be a concrete thing, but the template engine, you need to sort of pretend it has a type for now. So let's see, coming back up, we're back to the question of how to represent all this stuff.
Everybody knows that relational databases.
Yo, Tombo.
Because they use joins.
Thanks so much for subscribing with Prime. Appreciate it. Those Bezos bucks. Thank you. Thanks for hanging out. Welcome to the channel and enjoy the emotes. Those hot emotes. Appreciate it, my friend. Tombo. All right, so how am I going to do this though? Let's see, all type families, all directions, and then the width situation, right? We talked about this a little bit. So if we have all type families, then width can kind of be 0. It doesn't matter. We can just generate it once with 0. And then for the other ones, we can do types.int family. Then we're gonna, let's make like a new thing, var int widths, basically. You have a base class for families and specific classes that inherit it, so you won't have to do the switches. Yeah, so the key thing, it's a little bit confusing why we can't do that, but basically the reason is that Let's take a look at the generated code for one of these examples. Distinct is a good example that we like to look at. The generated code here, which is hard to read, it's very, very important that this column this is a sort of generic column in a sense. But it's very, very important for performance that this column value, it isn't like an interface that has all the methods that we want on it, like .get. It actually has to be a concrete struct, like this slice bool thing. And the reason for that is that it's too slow to use interface calls in the tight loops that we're writing to make them as fast as that we want, right? So this call, you could imagine that this call here was actually an interface that contained all of the type specific methods that you might want. So you wouldn't have to make switches, but unfortunately it's not fast enough. There's some other additional problems. Like let's say this was an interface. The question is what value would .get return on this interface? Well, unfortunately, since we wouldn't have a type specific column that we were looking at, we wouldn't be able to return a type specific value either. Like this is the Boolean column, so it's going to return Booleans. But let's say it was an int16s. We want this thing to return int16. And so that's another challenge. You would end up having to have either type specific stuff everywhere, or you'd have to return a generic interface here as well. So like you could return a datum. And this is how things used to be in Cockroach. It's like the returned values for everything was this generic interface called datum. And yeah, that just sort of introduces even more pointers, even more indirections, even more slowness, and it's just not efficient enough. So that's why we have to go through all of these irritating lengths to make type-specific code and type switches and generated code and stuff like that. I don't know if that makes sense, but that's the idea. So let's say we had this. What if we had all directions here? And then the key thing would be that we have var int widths, int 64, just int maybe. And then 64, 32, 16, I guess. Now, what would this look like? Let's say we have all type families, 0, all directions. Int widths. Portuguese Captain, it's been a hot second. How's it going? Nice to see you on the stream. Hope you're having a good Friday. We're just doing we're going back to our roots here on the stream. Doing some Execgen like we used to do back in the day. How are you? I hope you're going to have a good long weekend starting now. Yeah, I understand the busyness. I truly do. How's your new PC, by the way? Have you gotten to use it much? It had a good name, if I recall correctly. So the only thing that's sketchy about this now is that this thing is now like a concrete value. Well, I think it's fine because there isn't an execgen let for it. And what we're going to do is we're going to do a pre-processing pass and collect all the things with execgen let. Then for each of the things inside of these little instantiate declarations, we're going to check to see whether we have a let that matches them. And if it doesn't, we'll treat it as a concrete value. I think that'll work fine. All right, so you guys ready? You guys ready to just like try to implement this thing? I'm not sure how well it'll go, but we should try it out. Frostburn, yeah, hell yeah, dude, Frostburn. It's running well. Yeah, the PC's great, dude. I mean, look at this shit. It's like so clean and crisp. That 1080p that's really enabled by the PC really makes the stream get to the next level, in my opinion. So I'm all about it. Absolutely all about it. Yes. Can't do 1080p on a Mac to Twitch. It just does not really work, unfortunately. At least without maybe some like external GPU nonsense. It's just is not powerful enough. Yeah, maybe CPU also. All right, so how are we going to do this, you guys? Here's what we're going to do. We're going to go back to our big old parsing engine. I feel like we might want to get a little new file for this stuff just because it's a little bit different. Like, well, I mean, it's all related to template, but I feel like maybe having another file for like the instantiate thing might be kind of good. Like we'll kind of have two new passes. That we'll do the instantiate pass where we search for instantiates, and then we'll have the let pass where we search for let. Well, no. The instantiate pass is going to happen at the same time. It's going to happen at the same time. Oh, you know what we also need to do, you guys, though? Ugh, I forgot about this. There's one more step. All right, I wish we need like a little to-do list here. We need a little to-do list. What can I use for a to-do list? I'm just gonna make a little to-do.md that lives in the Execgen package. Where is that? Okay, so to do. We need to add parsing for execgen let. Add parsing for execgen instantiate. Then we need to add detection of, it's sort of like non-concrete template calls, and replace them with a lookup table. The lookup table will use, yeah, so this is like kind of the thing. The lookup table, right? The lookup table will be generated during Execgen instantiate and possibly also while finding concrete template invocations. The lookup table will transform dynamic values into concrete template calls somehow. All right, so this is basically the blueprint. I don't know if this makes sense. Like, okay, let me show you an example of this lookup table business, right? Let's say we have this callback.spans call that we've made. This is like the dream. This is the dream. This is the magic step. We have to convert the runtime values of each of the template parameters into some kind of lookup table lookup, right? So yeah, we have to generate like a little stub that does this stuff. And instead, yeah, it's going to be a little stub that checks the runtime versus the things that have been created in instantiate. You guys get it? I kind of get it. I sort of get it. Maybe we could write a test case. Let's make a new test case here called, it's like, this is going to be called like instantiate or like vtable. Is this a vtable? Who knows what a vtable is? I feel like this is basically what a vtable is, but I don't actually really know what a vtable is or anything like that. So I'm sort of loath to call it a vtable. I'll just call this the instantiate test. Instantiate. We'll just make this, what the heck? No, just stop this. Okay, so the instantiate test, it's going to have a test case that looks like this. And the test case is going to do something like this. Oh, yeah, check this out. So A is going to take a runtime Boolean, right? Input bool. And it's going to invoke the template using the runtime Boolean, which is freaking crazy. And the point is that we've got to do execgen instantiate of true and execgen instantiate false. So we can do let tests later. vtable is mostly for dynamic dispatch. Function calls, not type downcasting. Is this called type downcasting? I don't know what this thing is called. So this is basically going to be what our test case is. And our output, I don't really know what our output's going to look like yet, but it's going to need to have like this little lookup table thing. All right, so let's go. Let's make this happen. Where's the input? Where's the first function that we call here? Replace and expand templates. Expand templates. Okay, so there's going to be a new step. Find template funcs is going to happen. Then there's also going to be something called, well, this is actually just part of find template funcs. So find template funcs is a thing that searches around for func decals, and it's going to get their decorations, and it's going to find templates that look like Execgen template. Rainbow brackets plugin not available, dude? Does it say that in my thing? Oh. Update available. Update. Now I've got to restart, whatever. Let's just ignore that. So we're going to make a template regex, but we also are now going to have an instantiate regex. So this is going to look like execgen instantiate. And it's going to be the same thing because it's going to take n parameters inside of brackets. So this is going to match execgen instantiate. All right. So here is where we're going to also search for our instantiate declarations. And let's actually, okay, so we need to say var execgen dec positions int, because we might have a bunch of these decorations that we want to remove, I guess. Except it's a little confusing, honestly. Because as we delete things, we want the positions that we're going to be trying to deleting also change themselves. Yeah, I'm not sure how to do that. Whatever, we can look at this later. So we'll also be searching for instantiate things, and we'll be searching like this. If matches is equal to instantiate re dot find string submatch dec matches is not equal to nil. Okay, so here's where we're going to be found an execgen instantiate declaration. So we'll do this again. It's honestly exactly the same code. We could probably simplify this a little bit. So why don't we go like this? We'll say var we'll make a little function. So we'll say func parse template decal. It's going to take a matches regex dot match. Not called match. What is a match? It's a string. And it's going to return template bars. And it's also going to return an integer, which is the location of the declaration. And we'll basically just copy all this stuff. But we don't actually have this I thing. Okay, we don't have to return this integer then. So basically this is going to be saying parse template decal takes a list of matches. It's more like template decal matches. Takes a list of matches from an execgen blah abc declaration and abc regex match and returns the trimmed list of A, B, Let's see. Yeah. Okay, so let's do that. Trim template decal matches. So we'll say template vars is equal to trim template decal matches of matches. All right, cool. So then we're going to do the same thing for instantiate, except the difference is that we're going to say instantiate args is equal to trim template decal matches like this. And I think we need to eventually, let's delete the instantiate comments as well. So we're going to get these instantiate args, and then we're going to need to come over here and write down a list of instantiate args. So we'll say var instantiate args list string instantiate args list equals append instantiate args list instantiate args. In fact, we could probably just inline this whole thing like this. Okay, very cool. And next up, what do we do? So process template funcs, find template params from runtime definition and save in func info. The next thing that we'll need to do is just add these. I think all we really need to do is enhance this func info thing. Instantiate args string. I guess the project is a bit different. We can say commands edit project updating Execgen to be better. It's sort of like adding runtime to template type, like value lookup table to Execgen for CockroachDB. What ID? It's Golang, my friend. Check it out. You can even type Golang or IDE and it'll tell you. So we'll say instantiate args. Instantiate args is a list of lists of arguments that were passed explicitly as Execgen instantiate declarations. Yeah? Okay. So back to what we were doing is that we've got this args list, and then down here we can actually just say info.instantiate args is equal to instantiate args list. Yeah. Okay. So now that we've done this slight little bit of parsing, what do we do next? This is where we replace the template function with a const marker. I think this could be a reasonable time to add the instantiate variants. We could do that here. So we could say for I in range func info dot instantiate args. I think we have a function for this called like create template func variant. It takes an f, takes an info, and it takes an arg. So we just say info.instantiate args of I. Wow, this was actually really easy, shockingly. Oh wait, but they need to be dst.expers. So I guess we have to say exper list is equal to make dst.exper len info.instantiate args of I. I guess we can just say I args. We'll say like this, exper list. Then we're going to say for I in range, for j in range, args exper list of j is equal to dst.new ident of args of j. Then we can pass an exper list like this. All right, sick. So this is going to make new template func variants for us. And then the question is we have to now we need to generate the lookup table that allows us to convert runtime values into template values for the types for the args that are template args for the template args. Okay, so this is going to be sick. What is this going to be like, basically? I think what we need to do here is basically what we're going to do is we need to like, okay, let's think. Let's think about what this should look like over here in our test case. What we want to have is something that's like func b runtime to template or something. And it's going to take a input bool. And then what it's going to do is it's going to say switch input. Case true. Case false. B true. B false. It's very simple, actually. So it's just I'm going to make one of these things, basically. I need to make sure to propagate return values, too, which is kind of weird. But I should be able to do that, no problem. Okay, we'll make this happen. Oh my god, isn't this exciting? I'm so excited. So we're going to say decal is equal to dst dot func decal. And what fields do we need to fill on this thing? We need to fill its receiver, its name, its type, its body. Okay, so for the receiver, it's going to be nil because it's a function, not a method. Its name is going to be fmt.sprintf. Should I have it? Let's see. What do you guys think? Should it be called B runtime to template or runtime to template B? B runtime to template. I'm going to do B runtime to template, maybe. So we're going to say format S runtime to template. In fact, I think what we should do is probably make this into a const. So we're going to say const runtime to template name. Runtime to template, because we're going to have to reuse this thing later for sure. To invoke it. So S, and it's going to be info.name. We don't have a name. It's info.decal.name.name. Except this thing also has to be a dst.new ident, doesn't it? Like this. All right, cool. And then we're also going to pass our runtime to suffix, runtime to template suffix. All right, so then what is the next thing to fill in? It's the type. The type is a dst.func type, which needs to have what? It's a func bool. Oh, whether it's I see. So we're not going to use this thing. Actually, I don't know what this is about, but I'll just ignore it. So it needs params and results. Incoming params, non-nil. So the params are going to be, what are the params going to be? It's going to be exactly the same as the input. So params are going to be info.decal.type.params.clone. Or no, dst.clone? dst.clone, like this. Okay, and then the return parameters, it's going to be the same. We're literally just cloning this thing, actually. Results, dst.clone, and then we have to cast this, I guess, to field list. Honestly, could we just clone the entire type? I think we could. dst.clone, info.decal. Oh, wait a minute. No, we can't. No, I think this is right. I think we do clone it. Info.decal.type. We just clone the whole type. And then cast it to dst.functype. All right, sick. Now the body is where we actually do the main magic. So we're going to say body is going to be, it's a block statement. Okay. dst.block statement list. dst, and this is going to be a dst.statement, right? Okay, so what is the list going to have? The first thing is it's going to be a dst dot switch statement. And the tag, we're going to fill all fields here. What is DST? It's basically this, it stands for Dave syntax tree, but it stands for decorated syntax tree, but the guy who made it is also named Dave. Basically, it's a little extension on top of the Go AST parser that allows you to edit the source code more easily without losing information about where the comments live. It's basically just an AST package that's been improved. So the tag is going to be, oh, this is actually a little bit tricky because what if we have multiple statement parameters? Let's actually go back and make our example more complex. So we're going to have Boolean and an I int. So we're going to say true 1, false 1, false 2 to make it tricky. Thank you for the follow. So we're going to say if t x equals 3, then we're going to say else if I is equal to, I guess we have to say switch I case 2 just something like this, no big deal. So to make this work, what we need to see is, since we've got a true 1, false 2 thing, we need to be able to detect. It's a little hard, honestly. I int. We need to find a way to switch on all of these things. But given that each switch can only be looking at one thing at a time, we need to make a hierarchy of switches. And I guess to do that, we really should be keeping a map. Ugh, it's a little gross, TBH. We kind of need a map from the first parameter to a list of all the rest parameters, I think. Right? I mean, what we want to have in the end is case false, switch I. I mean, it's the same thing basically, but it's going to be true 1. Switch I, case 1, case 2, be false 1, right? Be false 2. So the question is, how do we how do we generate this code, this second switch? It's a little annoying because we don't want to generate all combinations, just the combinations that exist. Well, I think it's going to have to be recursive, which is a little bit annoying also. So let's think about it for a second. It's sort of like, okay, let's say we had, recursively expand one variable at a time. Exactly. It's just thinking about it, it's a little bit tricky. So I guess we'll say for I, let's start with a for loop just to get started here. So we'll say for I in range args. for args in range info dot instantiate args again. We'll say if len args is greater than 1. So if len args is equal to 1, this is our base case, right? If len args is equal to 1, what we're going to do is we're going to emit. We need a new function. You're right. We need to have a new function called func generate switch statement lookup. It's going to take in. It's going to take in a list of args, a list of lists of strings. So this is going to be an args kind of thing. That's it. I think it's just going to take that and it's going to return a dst.switch statement, right? So here's our base case. Our base case is if len args is equal to 1, then we return a simple switch statement, which we were just writing. It's going to look like this. Well, ret is equal to dst.switch statement. The tag is going to be, right, so what's the tag at this point? No, we also need to pass in another thing, which is the nth value. Like, gosh, this is annoying. I think we need to pass an int, and then the, well, I guess we could say remaining template params, like this, maybe? If len remaining, actually, never mind. Okay, this is fine. So, all right. So the tag is going to be remaining template params of 0. Except this is not allowed. We have to make an ident out of it. So we have to say dst.new ident, like this. All right. Decorations we ignore. The body. Here's what we say. We say for I in, this is the base case. For I in range args of 0. For I in range of arg 0, we say ret.body dot, nope, we have to say body is equal to, this is supposed to be a block statement. Block statement. So I guess what we want to make here is like a statement list is equal to make dst dot statement len of args 0. For I in range args 0, we'll say statement list of I is equal to, okay, so body has to be made of case clauses. That makes sense. So we have to make a dst.case clause. And the list is going to be, the list is the things that are the matches, essentially. And the body is going to be what? Let's see. This is crazy, right, guys? So the list is going to be a dst.expr, which matches the dst.ident of args of 0 of I want to say. And then the body, this is going to be the key thing. This is going to be a dst.callexpr. Oh, but does it have to return too? That's also brutal. We have to be able to know whether we are in a returning context or not, which is a little bit annoying. But let's just do callexpr for now. We can fix the return. But body has to be statements, doesn't it? Body has to be statements. So it's got to be a dst.statement list. And inside is going to be a dst.func statement. How do I get a statement? Like a call a function. What's that called? Invoke dst. I thought it was a call expr. An expression followed by an argument list. I think a call expert is a statement, weirdly enough. No, it doesn't seem like it is. Looks like we look at it over here. So it's an expert statement. How could I forget it? So an expert statement is something that just calls an expert. Expert statement, x, dst.call statement, call expert. Then we fill in a bunch of shit.
I have to narrow down the search. How are you going to do that?
So the function is, this is an expert, function expression. So the function expression here, this is where we have to generate the concrete call expert. We have a function for this. The args are going to be what? I think we can reuse some code that we did for this already, right? Generate. Where do we do this? We do get template variant, create template func variant, find concrete template call sites. Where do we do the thing where we replace? Where do we replace the call experts? I don't remember where we do that. Replace template vars? Is it this? So replace template vars removes the template arguments from a call site of a templated function. Fun, nil, sag, dude. I think this is right. So replace template vars removes the template arguments from the call site of a template function, returns the template arguments that were used, and a new call expert that doesn't have the template arguments. That sounds exactly right. So what we want to do here is basically... Oh, but crap, we can't, this is annoying because we need to, the recursion is difficult. The recursion is difficult. We have to say, because we need to say remaining args and then the current args as well. So it needs to be like this, cur args string. Oops. Dude, this is epic. This is epic. Never mind that it's extremely complicated. It's definitely epic. Okay, so cur args. So for I is equal to remaining args, remaining args, remaining args, remaining args. Then what we do is we say like this, arg list is equal to append cur args remaining args of 0 of I. So this is our full arg list now. And then what we want to do is we want to call replace template vars. So this also needs the info, func info. And we need the call expert. So we need to construct an old style call expert. So the call expert is going to look like this. Call is equal to dst.callExpert. So we're gonna have a much more fun than nil right now. The true fun here is going to be called a dst.newIdent info.decal.name.name. The args are going to be the original arg, so meaning... Oh, this is complicated though, because we also need... We not only need the we need the concrete args and the template args together. So, oh, this is brutal. This is rather difficult. I guess this should be called cur template args. Remaining template params, remaining args. I guess we just need a non-template args, basically. I don't know. So the args are going to be a list of experts. I guess this can be non-template args. dsc.expr, maybe? So we're going to say arg list is equal to append. Dude, this is deeply confusing. Actually, okay, what about this as a concept? Let's change this back to cur args. Let's actually make it a dst.expr instead of a string. And what we're going to do is we're going to keep appending new dst.exprs to this thing, and it's going to include the original non-template args, which always have to come at the front. Hopefully. I feel like I don't actually guarantee that right now, but I feel like we need to. So, yeah. All right, so this is fine. We get cur args, and we're going to say arg list is equal to append cur args, and then we're going to say dst.new ident remaining args of I. All right. The args are going to be arg list. The ellipsis is false. The dex we don't need. So this is our new call expr. Then we call it with replace template vars. And this thing is going to return a new call expr. Why does this return the... Oh, it doesn't. Template args plus new call. So we can ignore the template args because we already have them. We go like this. We got our new call. Then we're going to give to this expr statement a call like this. Yeah? Does this make any sense? I have no idea. What's up, P4RI? How's it going? I feel like there's something wrong. Let's see. No, this is right. All right, so we got our statement list. We got our case clause. We've got a bunch of case clauses. There's something about a default value. Why don't we... We'll skip that for now. So if len remaining args is 1, we go like this. Okay, so then the question is, what's the non-base case? I feel like the non-base case is it's similar. And so we'll just return ret here. So recursive case, we have more args to deal with. Okay, so here's the crazy stuff that we have to do. In the recursive case, what we need to do is assemble, or is it that crazy? Maybe it's actually kind of simple. So we're going to say ret statement list. I didn't fill this stuff out though. I need to say ret.body.block. Ret.body.list is equal to statement list. Okay, so in the recursive case, we say for I in range, remaining args of 0 again. We need to say, I guess what we should do here is honest. Well, we need the same thing. Statement list is equal to like so. Looks like this can come up here. What is the statement going to look like? Let's go back and look at our test case. We need to have a new switch statement that's customized to just the values that we're going to see. Yeah, that's the thing that's really confusing here. Oh, you know what's really confusing is that, oh my gosh, I didn't even get this right, I don't think, is that we actually need to like create some sets or something like that, right? We need to say for I and remaining args, we need to make a map, like grouped args is equal to make map string. And then it's going to be remaining args is going to be another string list. So then we're going to say, or is it actually a string list? It's a string list again. So for I and remaining args, we're going to say grouped args of remaining, grouped args remaining args of, grouped args of arg is equal to, okay, now what the heck am I doing here? It's like, we need to say append grouped args arg, and what are we adding to this exactly? It's going to be, so confused. Okay, what is remaining args? Remaining args is a list of the concrete instantiation. So let's write this down. Generate switch statement lookup. Remaining args is a list of lists of actual instantiations. For example, if we had instantiate red, green, or red potato and red orange and yellow orange. Remaining args would be red potato, red orange, which is not that confusing, but it's like we have to like group them differently. So it's, I was just getting a little bit lost. Yellow orange. So basically the idea here, yeah, this is messed up. This is really messed up. We need to like do something a little bit differently. It's not len remaining args is equal to 1. It's len remaining args of 0 is equal to 1 is what's really confusing. So it's like if we only have one argument in our list of lists left. And then this is not right either. It's for I in range remaining args. And then this is actually remaining args of I of 0. Wow, that's very confusing, but that's okay. I think that makes sense though. So for each arg in remaining args, for each arg list in remaining args, we're going to say grouped args of arg list of 0, here we go, is equal to append grouped args of arg list of 0. We'll say like first arg is equal to arg list of 0. We can inline why is this not working? To forget my key shortcut, I always get a little confused. Extract variable meta alt v. I thought this is meta alt v. Is it because this is not valid? Yeah. Okay, so first arg. Okay, so then what we've got, grouped args is now this thing that's like all of the different combinations per first arg. I think it kind of makes sense. Then we can actually generate this list properly. So we're going to say statement list. So we'll say for I in range grouped args. So it's for first arg in range grouped args. Dude, this is absolutely bonkers. Rest args in range grouped args. We're going to say statement list of I. No. we're going to say, yeah, this is not right. Just the len of remaining args altogether. This is actually not right either, is it? Because it has to be unique values. Anyway, I'll just assume that everybody's made them nicely unique. And if it's broken, then somebody will fix it themselves. So here we have, let's just put this in here like this. Go down here. We'll say statement list is equal to make statement len of grouped args. Okay, here we go. So first arg, rest args, statement list of I, var I int, I plus plus. Statement list of I is equal to dst.case clause list dst.expr dst.new ident first arg body. Now this is the recursive step. dst.statement, then we recurse. We call generate switch statements lookup. This is actually bananas. Info. The cur args. We have to be continually generating the cur args. So let's do that properly. I think we actually have to clone this. So new cur args list is equal to append cur args dst.new ident first arg. So arg list. Remaining template params is what even is that, dude? What even is that? Oh, I think it. I think that we need to switch the way that we're doing things up. Instead of, I think I've made a little bit of an oopsie, because it's not like we're reducing the outer length of this string, really. We're actually reducing the inner length of this string. So I guess we say cur arg of int, cur arg int, and then we can just say template params, which maybe we already have inside of func info, do we? Yeah, we definitely do, which is nice. So we can get rid of this altogether. And this is going to be info dot template params of 0 dot. Doesn't have a name. Maybe it does. Fill dot names. 0 dot name. What is it? Yeah, sure. Anyway, all right. So I think this will work. Cur arg is int, and then instead of 0, this is going to be cur arg, right? Okay. Then remaining args is also confusing, honestly. But what we actually need to do is dude, this is so baffling to me for some reason. I think here's what we say. We say, instead of saying len remaining args of 0 is equal to 1, what we do is we say len, it's not len of remaining args of 0. We're still going to look at remaining args of 0. We're going to say, okay, remaining args must be a list of lists where the inner lists are all the same size. Okay, so we're going to say if remaining args of 0, len of remaining args of 0 is cur arg is greater than or equal to length of remaining args of 0 minus 1. Right, so let's say we had one arg and cur arg was equal to 0. It needs to be like this. So base case, we only have one argument left to handle. Generate the final switch case and create concrete calls to the template funcs. Okay, we're getting closer. We're getting closer. Recursive case, we have more args to deal with. Generate switch shape and lookup. This is now going to take arg list. The cur arg is going to be cur arg plus 1. Invert the array of arrays first. Yeah, you might be right. But there's a problem with that too, though, Sora, which is that we wouldn't be able to do the group bys as easily, I don't think. Right? Yeah, because you'd lose the grouping. You need to keep the grouping, or else you'll just make a combinatorial, a full combo of all of the different variants for each of the parameters. So I think we kind of have to do it this way, or keep a map of maps some other way. Okay, so then remaining args is going to be... Remaining args is just going to be everything. So, right. I guess this is just like... We should call this something else. Except we need to be careful again. So this is not remaining args of I of 0. It's remaining args of... For I in range... This is going to be cur arg, not 0. That's the trick. Here we go. I think this is going to be making sense very soon. So for first arg, rest args in range group, we don't even need rest args. How can this be true? I'm confused again. We do need rest args because we when we group these things together, dude, I'm so confused. So confused. I think I'm going to undo everything that I just did because I want to keep it. Because I think we should actually be editing the list of lists every time. I think it actually makes more sense to do it that way. Right? A, B, C, D, E, F, A, C, E, B, D, E would keep the grouping. I think the trouble is, what if you had A, B, A, D? What if you had A, B, A, C, B, E, C, E or something? I don't know. I feel like it would get confusing. I think you need it to be separate or else you lose information. But I'm not actually positive. I'm going to come back to this thing. So then when we do the recursive step, we can actually edit all of the rest args. I think it'll be fine. So when we insert into grouped args, what we need to do is say grouped args first args equal to append group args first args. Oh, we need to actually add something here, which is AA, BC, BC, EE. Oh, I see what you mean. Yeah, you might be right, actually. Yeah, you might be right about that, actually. It might be way simpler. I feel like I'm so close on this, though. Yeah. But if this starts to, like, fuck up, I'll go and take your suggestion, I think. Okay, so grouped args first arg. We're going to get arg list of 1 like this. The remaining template params are going to be rest args. And the remaining... Wait, no. Remaining template params are going to be remaining template params of 1 colon. And this is going to be rest args. I think this is basically all that we need, theoretically. I have no idea if it'll actually work. I kind of feel like it won't. But so then we're going to say ret.body.list is equal to statement list. And we say return red. All right. So we did it or something. So let's go ahead and now come back over here. And what we're going to do is we're going to put inside of our outer func decal this big switch statement thing. So we're going to say generate switch statement lookup. And now how are we going to populate this thing? We need info, cur args. Yeah, what the heck is cur args? It's confusing. It's basically all the arguments without the template arguments. How do I figure that out? All the arguments without the template arguments. We do that somewhere. We do that inside of replace template bars. It's this thing. I guess we could just run replace template args. No, it feels wrong. Replace template args. What we should do is make a new function that just does this stuff, I guess. Okay, so we're gonna say, we'll say, let's see, I guess it's like func get extract template bars. It's gonna take an info, func info, a call dst dot. Well, is it just, no, yes, you definitely need this. Extract template bars, and it gives you back the template args. Actually, what I want is extract template, extract, you sort of want two lists, right? The template ones and the non-template ones. Template args. So template function, call expr, and it's going to return a template args dst.expr, non-template args dst.expr. Okay, right? So basically we're going to take all of this stuff and put it over here. So new args are the new things, and I guess in this case we can say non-template args is equal to. Okay, then we just return template args, non-template args. And we're gonna say extract template args info call, template args, new args. Okay. All right. Var new args. Because we can literally just go like this. ret.args. All right, very nice. And then where we were gonna do stuff, we're gonna say, yeah, we've got to say extract template args info. The call is gonna be what in this case? It's, we don't have a call yet. Wait, we don't have a call yet. Awkward. Wait, what? We don't have a call expert yet. I think we need to, dang it. P info.temp field ordinal is equal to I call.args. I see. I think what I actually need to, dang it, I'm just gonna undo all that as well. Waste of time. Sadness, sadness. Okay, so what we need to do is just kind of say, we need a new function called like func extract. Well, honestly, what about this idea? Like we have this func info thing, right? It's got a func decal template param info. Like, shouldn't we just put in, we can extract them as we're doing this other stuff? Yeah, let's just do it in line here. So we're going to say name is equal to v. Name is equal to v. Break. If not found. Oh, God. This is looping through the template bars, but now we need to loop through the type params list and find the ones that aren't. Oh, wait. Delete template params from runtime destination. Wait a minute. Do we already do this? New param list. New param list. And dang it. we literally already do this. Okay, well, that's good. We just needed to realize that we already did that. That's awkward, but fine. Okay, so the new thing that we're going to pass in, cur args, is going to be I'm still so confused, though. Oh, you know what it's going to be? Is it's going to be an expers that are just, they're sort of just the copies of the formal parameters. So I think what we literally do is say n.type.params.list is going to be a field. So what we need to do is generate a new set of things over here. So it's like runtime args is equal to make dst.exper len n.type.params.list. Then we need to say for I in range n.type.params.list. We need to say runtime args of I is equal to p dot names of 0 dot name, and we need to make a new ident out of it. So new ident. Yeah. Okay. So this is going to be good. So we're going to pass in our runtime args. Our remaining template params. This is going to be what? This is going to be this is going to be info dot template params. What do we have in here? We need to extract. Well, this is annoying. Let's not no, we do need that. Okay, so we need to say info template. Let's like this. Template vars. Do I have it? Do I already have it? Can I just pass in template vars? Seems like it. Template vars. Then remaining args is going to be info.instantiate args, maybe? Okay, then I say cursor dot insert after decal. All right, y'all. Who thinks that this has any chance of working? I'm feeling like it's approximately 0 chance of working, but we'll see. And so what we're going to do is we're going to run the test case on this instantiate thing and see what happens. See if it even compiles. Okay, cd package cd call exec z call exec. Is there a difference in list of I is equal to foo instead of list append? Only if I think it's they're different semantics. If the list is pre-sized with a capacity, instead of a length, then append is about the same speed. But if it's not pre-sized, then it's going to be slower because it'll have to keep doubling in length until it's big enough. Go build. What's this about? Oh yeah. CD vendor, get slash pop, CD dash, C Execgen, go build. All right, so we're gonna say go test. All right, great. Index out of range 1 with length 1. And replace template bars. What? Index out of 1 and have range 1 with length 1. Is it this thing? Perhaps? So it's line 55. Call.args param.field ordinal. Okay. Okay, so I think this actually makes sense. We don't want to be using the field ordinal. We want to be using I. Not that complicated. We don't need to use param at all, I guess. Wait a minute. No. This is not code that we've changed. So I think that the fact that this was not working before is actually meaning that the caller is doing something wrong. Removes the template arguments from a call side of a templated function and returns it blah, blah, blah. Okay, so what is the new version of this that we're doing? It's basically this guy. And the arg list. Why don't we just print some stuff out here? Call. We'll just print it. We'll print out pretty print expers of call. B true 1, B false 1, B false 2. I mean, that sounds good. These look correct. Yo, hi, John. What's up? Let's actually make this a simpler test case, just to make sure that things are generally working. We're going to make all of this stuff, except we're going to remove the double nested stuff just to make an easier start. Okay, so we're going to start like this. Keep it a little bit simpler. Run again. So we're getting index out of range 0 with length 0. That is confusing to me. And it seems like we're calling it with a reasonable thing here. Okay, so call.args of param.field ordinal. Call.args. Is it that call.args is somehow wrong? I'm confused because I seemingly am printing them out. So why don't we print out the call.args? Format.println call.args len call.args maybe. So we see B true, true 1, B false, false 1. Input? input? What is this? Let's make sure that we're not getting down to the more advanced test case for a second. So we'll just delete this for now. Okay, we're definitely not getting down to the more advanced test case. So it says be true, true one, be false, false one, and then input one. So where is this coming from? It's like a different call, actually. It's a different call, which is interesting. So what that says to me is that we've actually completed our job the first time around. So why don't we actually print out what happened here? Why don't we print out what happened here? Did we get this far? Format.println, yay, we've created pretty print expers of ret. Pretty print statement, it's of ret. Okay, so let's see if we got this far. Okay, we did not get that far. Should we use the debugger? Why don't we use the debugger? All right, so remaining args is what? We've got true and false, so that looks good. Remaining template params is t, which looks good. Cur args is nothing, which looks good. Right? Cur args is nothing, which looks good. Yeah, okay. So we continue along. For our remaining args, okay, so we leave this, done, great. Ret.body.list, okay, so we've finished our ret, which is interesting. Our ret now has tag t, body, case true, then call expert. So that seems legit to me. Oh, is it that? No. So we finish inserting our decal, which is kind of cool. Insert after, then delete. Oh, do you know what I think the problem is, you guys? It's that when we, oh, I think I know what it is. It's that when we finish doing this stuff, then our later preprocessor goes and pre-processes it again. And it's kind of like no longer valid at that point because of reasons. I think we just haven't finished our job here. So finds all functions annotated with Execgen template, returns a function for each of them, right? So we're gonna finish this. We're gonna come out over here now. Then we're inside of replace and extend templates. You know what I should really do is I should print out everything at this point, just see what it looks like so I can understand what's up. So I think like things are going fairly reasonably actually. So what we can do is say format.println f dot. How do I like format this thing again? Verbose. How do I decorator.fprint? Okay, so we're gonna say decorator dot print of f. Okay, so we're gonna print out what we've got halfway through and see what that helps us with. So we print out. So here's our new file, guys. Check it out. We got package main A input bool B input. Now this is wrong. I see. The issue is that we need to replace this with the like switchy case. This is also looking wrong, but we're getting kind of close. We're getting kind of close. B runtime to template, switch T, case true. And we need to, yeah, I mean, T needs to be here. There's a bunch of stuff that's wrong. But it's getting kind of close, which I think is kind of cool, actually. So yeah. The PC keyboard, we got the keyboard shit, we got the PC thing. Yeah. I need to update some of that blog posting stuff. All right, so we're getting really close, you guys. We're getting really close. We need to do the following. I think I know what it is. It's that when we... Oh, no. It's these two. These two are the issue. I'm fairly sure. We need to fix these guys. So when we generate our call expr, this args list is just wrong, I think is what's going on right now. Remaining args. We need to replace template bars of call. I don't know, I'm confused.
I have to narrow down the search. How are you going to do that? By guessing.
Yeah, I'm actually quite confused. It's not just replace template bars that we need to do. There's another thing that we need to do. It's the one where we change the name of things. Yeah, it's this guy. Replace it with its mangled template function call. This is key. This is key. Get template variant name. This is the key right here. This is the key. In fact, I don't understand why we don't just do that in one step. I think we should just do this in one step. So I'm going to fix that right now. So we're going to say ret.fun is equal to name. We can inline this one as well. There we go. Okay, this is going to get a little bit more clear now. Let's try it again. Undefined name. Okay. So new call dot name. New call dot fun dot name. What happened here? I see. Oh, it's a... I see. It's a little bit irritating because... So we'll just say new call, mangled name, string. So we'll just return it as, I guess we'll just say, man, this is, oh, it just returns, I see, it returns a dsc.ident. So we'll say new name is equal to this, and we'll say ret new name dot name. All right. Okay. Very good. So we don't care about the new name here. But over here, we certainly do. New name. New name. Alrighty. How about this? Hey, it worked for one of the cases. Oh my god, and I think it actually did what we wanted. So let's get rid of the more complicated case for a second. We're going to run again, but we're going to run with rewrite. Let's just make sure to run just with instantiate. Run. I think we broke something else, but that's fine. So we're going to say run test execgen. Or is it test data driven? Test data driven. Test execgen. Nice. So that worked. And let's take a look at what it wrote. It wrote. So here's our new output. We got A input, and it calls B input. That looks broken. This makes no sense. So this needs to be fixed. This needs to say B runtime to template. And then, but let's check out runtime to template. Runtime to template also needs to take the argument. So we're still not quite there. But we're getting closer. We're getting closer. So let's go back to our new runtime to template. We need to instantiate arguments for this thing. So args is going to be... Wait, but we've cloned the decal type. So how come this doesn't work? Oh, is it because that we've edited the decal type to... We've edited this decal type. Unfortunately for us, which is weird. Old param list is equal to n.type.params.list. And then down here we can say monomorphization machines are your hobby? Hell yeah, dude. Old param list is going to be used here, basically. Decal.type.params is equal to old param list. I don't know. This is jank. You have no idea what it is? Yeah, that's okay. That is absolutely okay. So let's take a look at what it looks like now. Now we're at least passing this stuff in. This is looking sick. So B, look, check it out, guys. B runtime to template T bool. Switch T, case true, B true, case false, B false. So this, we're doing the expansion. This stuff needs to be fixed. We need to delete these decals for sure. But that is okay as well. And the last thing that needs to be fixed is this. Instead of saying B of input, we need to say B runtime to template of input. And that's going to be kind of tricky. I think what we need to do for that is what exactly? We need to detect when we're calling things with non-concrete. You see, we've got this, okay, find concrete call size flaws, all call express with the input func decal that do not contain template arguments and thus can be immediately replaced. And we have to like somehow know that this one's going to be like a special lookup type guy. And how can we know that? I think what we'll do is we'll, inside of the infos, we'll call it, we'll detect that it's an instantiate args one. So we're going to basically go like this. we're basically going to say, within the input functical. Oh, I see. Interesting. Okay, so what we need to be doing here is all arguments are concrete since the call site isn't within another templated functical. Ret. Find concrete template call sites. Oh, and thus can be immediately replaced. Oh, I see. Well, that's actually a little bit annoying. Yeah, so it's like this is the critical moment. Critical moment. We need to know whether to replace with concrete input args or to propagate. Oh, you know, I have a better idea. Why don't we just, instead of B of input, can't we just edit B in this case? Instead of just deleting it, can't we just edit it and replace it altogether? I feel like that would be really cool. Yes, CockroachDB does support geographic data inquiries. Yeah, it does. It does. It does. Check it out. It's like it uses like libproj and stuff like that. It's kind of similar to Postgres. We use this Postgres's whatever it's called. They're like Geo API. We implement that. No, I think we do need to change its name. I don't know. I'm very confused. Play with concrete input args or to replace the call with the lookup version. And how can we know that, right? Basically, we're going to say, I think it's actually maybe kind of clear. It's like if info dot instantiate args is not equal to nil. Yeah, so I think this is a special case. If instantiate args is not equal to nil, then we're going to say, okay, so what do we say? We say cursor dot replace call expr. And what do we do inside of this call expr? We need to sort of synthesize. Well, it's actually, we just say cursor dot, we actually just say n dot fun. I think we can just edit it. We can just say n dot fun is equal to dst.new ident. You tried Supabase with Postgres but didn't get it to work. Interesting. Yeah, so Postgres is basically what we implement. So I think you should be able to use Cockroach with that. No, you're all good, man. So new ident, and we're gonna say info dot. Yeah, right. So what was our special name thing? It's called runtime to template. Runtime to template. So let's extract this out into a const that lives up here. We're gonna say new ident of fmt.sprintf s info.decal.name.name, comma, runtime to template suffix. I think that's all I do, dude. And then I just say return true. Okay. No, it didn't work. Oh, you know, it's because it has to... Actually, I don't know. Anyway, guys, I actually got to run, unfortunately. This has been super fun, though. I just have to cut the stream off a little early because I've got to go to a birthday party. So I'm going to find something to raid real quick. Hopefully I'll get something done with this pretty soon. I think it's pretty fun. I love this meta programming kind of stuff. You know, I hope you guys like it too. Is there a Discord? We have a Slack. Should we make a Discord? I don't know. Do we even have... It's a... cockro.ch Slack. Yeah. No thanks. Oh man, I have to screenshot this because there's a debate about whether we should have a Discord or a Slack. I'm gonna have to screenshot that. Anyway, so let's check out who's on Twitch here. Science and technology. Okay, who's around? Coding Java Spring. Vimlark. Melky. Terraria meets Factorio. Okay, this seems fun. Let's raid this person. It's kind of like a gaming thing, but hey, why not? Or random projects in Rust. What about this guy? He doesn't have a camera though. He's got loud music.
You know that.
We raided B Dougie last time, so I don't want to like overly raid. We can. Why don't we raid this fella? We haven't raided him in a long time. You guys all know this guy. Let's send them a raid just because why not? Whoops, that's not a thing. That is not a thing. That is not a thing at all. Well, bam. Okay, there we go. All right, so you know what, you guys?
Absolutely.
This has been a lot of fun. And I guess I'll just see you guys next time. Have a good weekend. Have an excellent week ahead. And I hope to see you guys next Friday. Alrighty, bye.